Today we're going to be going over the warm-ups for SOL 6.3 and SOL 6.4. SOL 6.3 covers integers, including ordering and comparing, and it also goes over absolute value. SOL 6.4 goes over patterns with perfect squares and square roots. So we're going to start with SOL 6.3. Question number 1 says, which of these lists is correctly ordered from greatest to least? First, we need to remember that when we're ordering from greatest to least, positive numbers are always going to be greater, and negative numbers are always going to be smaller. And 0 is going to be the point in the middle if it's included with the set. So looking at these different lists, I'm going to start by eliminating the answer choices where there are where the negative numbers and the positive numbers are not separate. So if we look at A, we have negative, positive, negative, positive, negative, positive. So we immediately know that those are not in the correct order. For B, we have all the negatives and then all of the positives. However, positive numbers are greater, so the positive numbers should be going first. So B is incorrect. For C, we have all of our positive numbers together and all of our negative numbers. For D, we have all of our positive numbers together and all of our negative. So now it's between C and D. So first we need to make sure that our positive numbers are going from greatest to least. 9 is less than 20, so both are correct. Next, we need to look at the negative numbers. Remember that on a number line, when we start at 0, it goes -1, -2, -3, -4. So a number like -1 is actually greater than a number like -4. In C, it is saying that -23 is greater than -16. Negative is like owing somebody money. Is it greater to owe somebody $23, or is it greater than to owe someone $16? It is greater to owe someone $16 because once you pay that debt, you will have more money more quickly. So C is incorrect, leaving us with D. Number 2, identify each true statement below. So in this first statement, we have 2 negative numbers. Owing $15 is better than owing $30. So this is true. Here we have a positive number and a negative number. Positive numbers are always greater. So this is false. Here we have a positive and a negative number. Positive numbers are always greater. So this is true. We have 2 negatives. We have owing somebody $23 and owing somebody $30. It is better to only owe 23, so this answer choice is correct. Here we have a positive number and a negative number, so this is correct because the positive number is greater. We have a negative and a negative. It is better to owe 77 than to owe 88, so this statement is correct, and -77 is greater. We have 2 negative numbers again, -100 and -120. It is better to owe $100 than owe 120. So this statement is false because it should be opening the other way. Finally, we have a positive and negative number. A negative number is never greater than a positive, so this is not correct. Number 3, what is absolute value? Absolute value is the distance of a number from 0 on the number line. It's important to remember that distance is always positive, so the absolute value is always positive. The second question says, why is the absolute value for 5 the same as the absolute value for -5? To answer this question, it might help to have a small number line Here's 5. If we find its distance from 0, it takes 1, 2, 3, 4, 5 steps. And for -5, it takes 1, 2, 3, 4, 5 steps. So that is a visual representation of why they have the same absolute value. Now we're going to move on to the questions for SOL 6.4. This says to identify all the perfect squares below. A perfect square is the product when we multiply the same number times itself. In order to identify if something is a perfect square, we find its square root. If the square root is a whole number, then the number is a perfect square. However, if the square root is an irrational number and decimal, then it is not a perfect square. So let's find the square root of 50. The square root of 50 is an irrational decimal, so that is not a perfect square. The square root of 64 is 8, so it is a perfect square. The square root of 125 is an irrational decimal, so it is not a perfect square. The square root of 16 is 4, so it is a perfect square. The square root of 0, the square root of 0 is 0, so that is a perfect square. The square root of 225 is 15, so that is a perfect square. The square root of 81 is 9, so that is a perfect square. The square root of 189 is an irrational decimal, so that is not a perfect square. The square root of 361 is 19, so that is a perfect square. The square root of 9 is 3, so 9 is a perfect square. Number 2, write the following exponents in expanded form and evaluate them. Remember that in exponents, we have the base, which is the factor being multiplied, and the exponent, which tells us how many times to multiply it. So 7 to the power of 3 says to multiply the base of 7 by itself 3 times. So 7 times 7 times 7. If we do this in a calculator, we do 7 to the power of 3, and we get 343. A really common error that students make is to do 7 times 3, but that is not what 7 to the power of 3 means. 10 to the power of 2 would be 10 times itself 2 times. So 10 times 10. And in Desmos, 10 to the power of 2 is equal to 100. 10 to the power of 5 would be 10 times 10 times 10 times 10 times 10. So I've multiplied it 5 times. And it's 10 to the power of 5 is 100,000. 2 to the power of 4 would be 2 times 2 times 2 times 2. And 2 to the power of 4 is 16. 9 to the power of 4 would be equal to 9 times 9 times 9 times 9. And 9 to the power of 4 is 6,561. 3 to the power of 6 is 3 times 3 times 3 times 3 times 3 times 3. And 3 to the power of 6 is equal to 729. 5 to the power of 5 is equal to 5 times 5 times 5 times 5 times 5. And 5 to the power of 5 is 3,125. 11 to the power of 3 is 11 times 11 times 11. And 11 to the power of 3 is 1,331. Number 3, the last question. What do we notice about the powers of 10 below? What is interesting about the powers of 10 and how they relate to their exponents is in the zeros. 10 to the power of 0 has no zeros. 10 to the power of 1 has 1 zero. 10 to the power of 2 has 2 zeros, and on and on and on. So 10 to the power of 7 is just going to be a 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. And to make this easy to read, we start at the end, and every 3 digits we add a comma. 1, 2, 3, comma, 1, 2, 3, comma. So 10 million.